So when we're doing long division keys on the first terms. Okay, synthetic division, not so much. And again, most everything we're going to do, we're going to focus heavy on. I'm going to show you one long division problem, but most everything else we're going to do, we're going to key on synthetic division because that's really a lot of the things you're going to do in here, and even a lot of things that you do in pre-cal. They're going to key on you being able to do synthetic division more than the long division stuff that we'll do. Okay, now, and if you haven't done division in a while, let's take you back to long division. If you had to divide 13, and you don't have to write this down, just kind of making it way here. If you had to divide 13 into 9,764, and I have to kind of flash back. In college, we were doing, I think I was in like Cal 2 or Cal 3, and had somebody came up and asked me, I think they were elementary education major, and they were like, hey, you're a math teacher, right? Or you do math? I was like, yeah. And they were like, can you help me out? And I was like, sure. They were like, well, I got to teach somebody how to do long division. And they were like, how do I set this up? What do I do? So they asked me, and I looked at them. And for about 30 seconds, I just had this blank stare on my face. I was like, okay, I'm doing calculus, and we're back to long division here. I was like, and after a little bit, I was like, well, you just divide, right? I'm like, I was like, I don't know. I was like, you just, and then finally I was like, well, will 13 go into 9? I was like, well, no. So I was like, you got to get a bigger number. And then finally the wheel started to click a little bit. So it was like 13 into 97. You got to figure out how many times it would go. You think it goes 5 times. 6 times would actually be there, maybe 7 times. We've got 7 times 13 would be 91. We're going to subtract it to get 6. We're going to bring down the next number. We'll divide 13 into 6. Go there. That's going to be 65. We got 4. And then finally the wheel started to kind of pick up on what we're doing. So basically you divide this one into here. And again, you key on the first terms. 13, will it go into 9? Well, no. Then we go to the next term. Will 13 go into 97? It does. And then we're going to multiply this times this. Bring this number here, subtract. Finally, at the end, we've got a remainder of 1. So we could answer that one as 751 with remainder 1, or we could do it as 1/13. We had different options we could do with how the remainder was going to be set up there. Okay, so if you haven't done that in a while, just think about what you do. You're figuring out how many times this will go into the first term, the first number. And if it doesn't go, then we go to the second number, and then we just kind of bring down, multiply, we subtract, bring down the next number, kind of keep going from there. Long division is the same way. If we take x plus 3 and divide that into x to the third plus 5x squared plus 7x minus 10, we're basically going to do the exact same process for this one to do long division with polynomials. Okay, so keying on the first terms, we've got an x to the third here, and we've got an x here, so we're going to take x to the third and divide it by x. Okay, if we do that, you go, well, that's not too bad. I'm just taking out a power of x, so that's going to knock this thing down to x squared. All right, so we're good there. Okay, and then we're going to do like we did before. We're going to do 7 times 13 to get this number. We're going to do x squared times, and really we're going to do it times both of these. We're going to do x squared times x to get x to the third. We're going to do x squared times 3 to get a 3x squared. And this is always a question I love to ask when we do this one. Where does this subtraction come from? How do we take 7 times 13 and get negative 91? That's just the rule, right? That after you multiply these two things out, you have to go back and subtract them. So same thing here. After we multiplied these two things, you've got to go back and just change these signs. That we've got to change these things with how this thing is set up. So we're going to change that to a negative x to the third and a negative 3x squared. So that now the first term is gone. We got 0 here, which is what we want. We've got 5 minus 3, which would be a 2x squared. And then we bring down the next term. Question.
Up underneath x to the third.
Okay, so now that we've brought down the next number, now we're going to key on the next two terms. Now we're going to take 2x squared and divide it by x again. Okay, so we take 2x squared and divide it by x. Again, we're going to knock out one of the x's. That'll just make it 2x. So we're going to put a 2x here. Okay, so we've got 2x times x to get us 2x squared. We've got 2x times 3 to get us 6x. Okay, and just like before, we've got to subtract these things because we always get this negative pops in here. So we're going to change this sign and then also change that sign. So this would cancel out. We're left with 7x plus or minus 6x. In that case, that would just be a 1x. And we got minus 10. Okay. And then one more time, we're going to key on the first terms. Now we're going to take the x here and divide it by the x here. So that's 1x divided by x, which would just equal 1. So we put a positive 1 there. If we do 1 times x, that's still just 1x. If we do 1 times 3, that's a positive 3. Okay. And again, we need to change the signs, change this, change that, and we're left with a negative 13.
Oh, okay.
Okay.
You just have to take another track.
So your final answer, if you write it out together, we've got x squared plus 2x plus 1. And you can either write the remainder, comma, remainder equals negative 13. You can also write that remainder as a fraction. So it could be x squared plus 2x plus 1 minus 13 divided by the x plus 3 that we had back up here. Okay. Mm-mm. So now we're going to show you a shortcut that you get to do. Yeah. So again, long division is just that. It's kind of long. It takes a good bit of time. We are not going to focus on long division. That even a lot of the problems in the homework that you will have to do, it may say long division. You can still do most of the problems with synthetic division. There may be one problem in the homework that you have to do long division, but most of the problems, again, even if it says long division, if it's set up the right way, you can do synthetic division. Okay, so for
you just multiply both of the terms, like if it's x plus you just multiply both of them.
Yep.
And then you divide it. You divide this. Like the stuff that's up here, you divide that like this.
Mm-hmm.
You divide that by x, like all of them.
Basically, synthetic division is a shortcut to use when the divisor, go back, way back here in your terms here. Remember the divisor, that's the number that's on the outside that you're dividing by. When the divisor is x plus or minus some constant, x plus 3, x minus 4, x plus 2. So if you're dividing by 2x minus 1, you cannot use synthetic division. It has to be x plus 3 or x minus 2 or something like that if you go through those. Okay, and again, we're not going to write down the steps because here's your steps here. Okay, so got the handout. So that again, there's a lot of steps to this thing. So we've got this in here, so you do not have to write the steps down because it would take forever to do this thing. So we're just going to keep this paper to the side there. We're going to keep referencing this paper as we go back through this thing. All right, so what we're going to do is we're going to take this exact same problem we had here with long division, and we're going to do it with synthetic division and show you how this thing's going to work. So we're going to start with x plus 3 divided into x to the third plus 5x squared plus 7x minus 10. Okay, and we talked just a few days ago that, again, if we're talking about standard form is they're in descending order based on the powers of x or whatever the variable is they give to us. In this case, everything is in descending order, so we're good here. Second thing you have to have, if there's any variable powers missing that are not present in your question, you have to include those powers with a zero coefficient, which basically means this. If we were dividing this problem and the x squared term here was missing, if that was gone, you'd have to go back and put in a 0x squared for this one, because with, back up here, you need all your terms to kind of line up when we're doing this one. Same thing here. We need all these terms to line up. So if the x term was missing, you'd have to go back and put a 0x here. If the x squared term was missing, you'd have to go back and put a 0x squared in its place. Okay, so everything is in order. Everything is lined up. So when we do this one, step 2 on our synthetic division here, again, we keep referencing back to this one, is we're going to draw this division bar upside down. And you're only going to bring down the coefficients. So you're going to bring down a 1 for the x to the third, a positive 5, a positive 7, and a negative 10. Okay, on the outside, step number 3, it says we're going to bring down just this c term we've got here, this constant. But when you bring this thing down, you're going to change it from a positive to a negative. And here's why we do that. Instead of having to change all these signs in here with long division, if we change it here one time, we've changed the sign. Now we don't have to do anything else to change all these signs up. Okay, and then the first term on the inside, always you're going to bring it down and drop it down underneath there. Okay, and then we're going to multiply. We're going to multiply negative 3 times 1, and that answer will go right there. So we're going to multiply negative 3 times 1 to figure out what this next number will be here. Because again, everything is upside down. So just back here, how we multiplied this times this to get these, it's upside down. So now we're going to multiply this times this to get here. So we're doing everything upside down to make this thing work out a little bit. Okay, and then you just add or subtract. 5 minus 3 is a positive 2. Oh, look, that's the answer we had right here. There's that positive 2. Okay, and then we're going to do the same thing. Negative 3 times 2 is a negative 6. Positive 7 minus 6 is a positive 1. Positive 1 here. Positive 1 there. There was the 6 we were looking for right here that we got earlier. So all those numbers are kind of lining up here. And then one more time, negative 3 times 1 is negative 3. Negative 10 and negative 3 is a negative 13. Oh, looky there. That's the remainder that we had right there. There you go. Okay, and to put it all back together, again, we know that this last number is our remainder that's here because we're with synthetic division, because you're always going to divide by x. All that's going to happen is this first term, instead of starting off x to the third, it's going to knock it down 1 power. So if this one's x to the third, this answer is going to start with x squared. This will be your next term down, which will be just x to the first power. This will be your constant. And then that negative 13, again, is your remainder. So we're going to do negative 13 and then divided by the x plus 3. Okay, and how much neater, cleaner, faster was that than that? Okay. Okay, so let's give you another one here. So let's change it. So on the outside now we've got a subtraction. So we've got x minus 2. Let's bump it up to x to the fourth.
But this synthetic.
Still in synthetic, yes.
It can be.
Yes. Good. And everything else we're going to do for the rest of the way, we'll only do synthetic division because, again, most everything that you do in Algebra 2, anything else we do in this part, synthetic division, and 99% of everything you do in pre-cal will be synthetic division. There may be one random time where you might have to do long division. So everything in pre-cal is, almost everything on it is based on being able to do synthetic division. So that's all we're going to focus on. All right, so again, draw the division symbol upside down. And leave two spaces because, again, you need this one for the coefficients. This is where you get to show your work in here. So we've got 1x to the fourth, positive 2, negative 5, positive 3, and then negative 1. Okay, drop the 1 down. And on the outside, take the 2 that's here, change it from a negative to make it a positive. And again, that way we do not have to change any signs down here because we've already changed this thing back over here. And here's where the math gets really easy. It's 1 times 2, which is 2. Add or subtract. 2 plus 2 is 4. 2 times 4 is 8. 8 minus 5 is a positive 3. 2 times 3 is 6. 6 plus 3 is 9. And then 2 times 9 is 18. 18 minus 1 is 17. There you go. So again, multiply that times that. There, there. Multiply there. Multiply there. Multiply there. Okay, and again, because this one started off x to the fourth, and we divide it by x, we're always going to knock it down to power. This one's going to start with x to the third, 4x squared, plus 3x, plus 9. And again, the remainder, they may let you just put remainder 17. They may give you a box that's got the remainder here, so it could be one of a bunch of different ways. We're just going to rewrite it as 17 divided by x minus 2. Again, they may just give you a remainder with a box in it, and you just put the 17 in there. So it could be all kinds of different options they may throw at you with math Excel.
Yeah, so like, where does this 2x3? One day. Yes, sir. Yes, sir.
Okay, so for example 3, let's go x plus 2 divided into x to the third minus x plus 4.
I understand.
Okay, so for this one, here's the main thing on this one. Notice we went from x to the third down to x to the first. We skipped over x squared. So what you have to do in this case is, there we go. That basically you got to know that there's a 0x squared. The 0 is going to be like a placeholder. That you've got to have all the powers of x, because if not, these numbers don't line up correctly up here. So this really is x to the third plus, doesn't really matter, 0x squared minus x plus 4. So that's what you've got to think about for this one when you do your division here. So it's 1x to the third, it's 0x squared, it's a negative 1x, and a positive 4. Okay, the 2 on the outside, change it from positive 2, make it a negative 2. Okay. Drop it down on the first one. And then we're multiplying. Negative 2 times 1 is negative 2. 0 minus 2 is negative 2. Negative 2 times negative 2 is a positive 4. 4 minus 1 is a positive 3. Negative 2 times 3 is a negative 6. Okay. 4 minus 6 is negative 2. Okay. And again, this one started off x to the third. So this first answer is 1 x squared. Again, we don't necessarily need the 1 in this case. Minus 2x plus 3. And again, they'll either give you a box for the remainder or they'll have you put minus 2 over x plus 2. All right, so given the choice, synthetic division or long division? Definitely synthetic, right? As long as you know the steps, that is way easier than that. That's ugly. I mean, that's just ugly when you look at it. Okay, now when you're doing synthetic division, here's a couple little things we can throw at you for this one. The remainder theorem. If you always need to check to make sure it works. Now, it's not the best check in the world, but this one works out okay. Basically, remainder theorem is a check for synthetic division. And for the check on this one, this is more of like I hate to say it's more of a calculator check, but it's pretty much like a calculator check. This is where you're going to evaluate the original expression which again in this case is the dividend. Remember, that's what's on the inside. Because divisor is on the outside, dividend is on the inside. That part of it. The original expression, the dividend, using the divisor in synthetic division. And remember, your divisor, that's on the outside. Okay, and when you do this, when you take this number and you plug this number back into the original expression, the answer you get should equal the remainder. So your remainder theorem answer you get when you plug in this number should also equal this remainder that's back here. So what we're going to do is we're actually going to take this problem we had back here and we're going to check it to see if negative 2 actually was correct. So sometimes you may get an answer and you may look at the number and you go, that answer doesn't seem like that would be. You may get like negative 96. You may go, that just doesn't seem like that should be the correct answer. You can go back and do remainder theorem to check and see if it actually works out to be there. Okay, so for this problem, we were dividing everything by negative 2. So we're going to evaluate negative 2 into the original problem, which was x to the third minus x plus 4. Okay, now I think the way that they do this, the notation on this one, the way they kind of set this up, a lot of times if they ask you to do it for in Math Excel, a lot of times is they'll do this. They'll say, all right, P of X is equal to this original expression we've got here. And then they're going to take this number we've got and they're going to say, all right, we're going to find P of negative 2. Why they use expression P in this case, I'm not really sure. I know they kind of differentiate that from to know that like f of x is always like the original function. This is just some way to kind of separate for this thing. Okay, so we plug in negative 2. And in those cases, if you notice, it's always in parentheses. So we're going to plug it in parentheses. It's negative 2 to the third power minus negative 2 plus 4. Okay, and everybody has a calculator. If not, there's one on the board you can borrow. And so from those, that's where we would just take this thing and plug it back in so that, your math is good and you don't get the wrong answer with this one. So we've got parentheses, -2 to the third power minus -2 plus 4. Oh, my bad. All right, try that again. Don't use the Casio that much, so we got -2 to the third power minus -2 and plus 1. Okay, so that answer is -2, which also was our remainder back up here at -2. So that does check, so that we get it there. Okay, now why they do that one? Why they have you talk about the remainder theorem is this, because sometimes on these problems, what they may ask you is, okay, we can use this remainder theorem to do this, but here's the big thing we're looking for. And this is kind of the next thing we're moving forward to on Monday that we're going to come back and dig into it a little bit more. Everybody good there? Okay, so one last thing we're going to mention here, and this will be it for the day, is there's what they call the factor theorem. And all it says is this: if your answer using the remainder theorem equals 0, then what you divided by is a factor of the dividend. And we'll take that last example we had and we'll tweak it just a little bit to show you how that thing would work out there. Okay. Now, again, to me, the remainder, and some of the confusing parts of the homework, and they do these on these questions, I don't understand why they do this. The problem will say, use the remainder theorem and do synthetic division to factor this thing out, do what you do. You're not going to do both. You're either going to do one or the other. So a lot of times in the homework, they're like, well, it says to do both. I'm like, no, you just pick one. Just if it just says find out what the remainder is, you can either do the remainder theorem or you can do synthetic division. They're honestly both about the same speed because of plugging in the numbers and evaluating. They're really not either one of those. Okay, so far, none of the examples we've had have had a remainder of 0. But here's what we're going to do. For this problem we had back here, let's say we were doing this one. If this last number had been, if we tweak this last example, if this last term here, if this instead of being a positive 4, if it had been a positive 6, everybody okay that this 6 minus 6 would have been 0? So basically what we've got back here, if we were taking x plus 2 and we were dividing it into x to the third minus x plus 6, that again, back here, we knew that this was going to be -2. If this is a positive 6, it's 6 minus 6. This will make this a 0. So if we went back and did this thing and we took -2 and we plugged it back into this equation, we know that if we had that, if we did this and plugged this one back in, we would get 0. So basically what that means, if you plug this number back in and you get this thing to equal 0, that means that you can actually take this expression that's here and you can factor this one as x plus 2 times something else that's here. Yeah, which means now you get to actually do some factoring skills. So this is a check on how to find. So if you get a problem that you look at it and you go, well, there's no way that I can take x plus 2 and divide this thing out and get something. If the remainder equals 0, it's saying, oh, no, you actually can do this. So here's what we'll do. And here's how this would set up. Let me actually show you. Well, actually, let me do this. Y'all go ahead and do synthetic division on that one. Here's a practice one. Do synthetic division with this problem and see what you get. Okay, and again, because we skipped the x squared term, we know we got to put a 0 there in for a placeholder. Okay, so we do our synthetic division. We've got this, and again, this means this is going to be x squared minus 2x plus 3. Okay, so what they would have you do for something like this is they would say, all right, if you can factor this thing, go ahead and show me what this thing would be factored down. So this one would be x plus 2 times x squared minus 2x plus 3. And then they would say factor completely. This is one that if we had one sign different, we could factor this thing more. And this is one probably in hindsight, I need to go back and change this problem just a little bit. But basically for that one, that would be if they ask you to factor this expression, or can you factor this one, you would say, well, if remainder equals 0, then yes, I can factor this one. And this is what this would look like in factored form. Now, if this was one sign different, you do what if here? What if it was that? Could you factor this a little bit more? Are there any factors of negative 3 where the sum would equal negative 2? Could do that, right? So then you can take whatever you've got left here and actually factor this out and make this an x plus 1 and an x minus 3. And I wish I had picked the problem so that that sign there had actually been negative, and that would have made this problem a whole lot easier. So I'll do that for future classes. Okay, and so that's kind of where we're going on Monday, that we're going to see if we can do synthetic division of this thing. And if we can get this thing equal to 0, then we've got something that we can then factor and then kind of work this thing on down. So your factoring skills, you've got to hang on to those because we're still going to need those.